Hi everyone, today let's solve Leetcode question called linked list cycle 2. So this question is basically very similar to the previous question called linked list cycle, but the only difference is that the previous question only asked to find if there's a cycle in the linked list, but here we have to find the specific node where the linked list cycle begins. If there's no such cycle, we want to return null. Okay, let me use the graph drawing here to help me understand. So let me draw a linked list cycle here using the red color. So let's say the head of the linked list cycle is h. And then we want to travel another, let's say, a distance to reach the starting point of the linked list cycle. And then we'll travel another linked list cycle, right? And let's say the starting point, I will use the t, right, for starting point. Okay. Now, the next thing, as we did the previous question, if you remember, we want to run the fast pointer and slow pointer all the way from the head until they met somewhere in the linked list cycle. So we'll use the fast pointer started here, slow pointer started here, and let's say they meet somewhere in the cycle. So they meet here. So the fast pointer and slow pointer at this position in the cycle. Okay. And let's further suppose the parameter of this cycle is b. So if we travel from this position all the way clockwise and go back to this point, the distance traveled will be b. Okay, now finish all this, we can actually derive the equation for the fast pointer and slow pointer. So the distance traveled by fast pointer is actually double the distance than the slow pointer because they are starting at the same position and the fast pointer has double speed, right? So we can actually write the equation here, f equal to 2s. And the other thing we have to know is that fast pointer actually traverse more than n cycles than slow pointer. We have fast minus s is nb. So n is here integer indicating how many cycles fast pointer are traveled more than a slow pointer. Okay, if we combine these two equations, we can actually get the slow pointer distance, which equals slow equal to nb, right? Let's call it equation 3. Now, how can we exactly find this nb? Well, let's think about here. So you see, if we for the slow pointer, it will travel all the way from head to this position, right? We get nb because this equation tells us. And how about the distance from the starting point all the way from the slow point and fast point meeting condition? Let's use different color. So if we're traveling from this starting point t all the way to the meeting position of fast and slow, and what will be this distance? So you see distance will be mb minus a, right? Because it had already traveled a distance before the cycle starts. So the rest will be mb minus a. And let's think about this. Once we have this distance equal to mb minus a, the rest distance from the meeting point to fast slow pointer to this t will be a, right? So let's use another different color and write out here. So see, if we travel from this point to this point, and this distance will be a, because you see mb minus mb minus a will be a, right? Okay, I hope my explanation works. Now we are left with the final step. Since we have a from the meeting point to the cycle starting point, and we also have a distance from the head to the cycle starting point, actually we can run the slow pointer from the head. We run slow pointer from here and to here, and simultaneously run this slow pointer to this position, and then they will actually meet at the cycle starting point if they are traveling thus at the same speed. Okay, although the graph is messy, I hope my explanation makes some sense. Now, let's dive into the coding part. Okay. So the first thing we have to consider is you need to the fast pointer and the slow pointer both at head, as we did in previous questions. And after that, we want to run fast and slow until they meet a specific point, right? And once finish that, we want to run slow and head until they meet and the cycle starting point. while fast and fast.next. Slow equal to slow.next and fast equal to fast.next. Okay, if slow equals fast, it means these 2 pointers has met somewhere in the cycle, then we have to immediately break the while loop, right? And otherwise, if we don't find the place where the slow fast meet each other, this means there's no cycle, and we just return null. Okay, now finish the first while loop. Let's check the second while loop. Okay, so for the second while loop, while head and head dot next. Oh, sorry. While slow does not match with head, they want to move slow to slow.next and head to head.next. So actually we are starting the slow pointer at the meeting point all the way to the cycle starting point, and we run another slow pointer from the head all the way to the cycle starting point. And since they have the same distance, they will actually meet at cycle starting point if they have same speed. Okay, if we finish all this, and the slow at head meter somewhere will exist this while loop, right? And we can safely return head, or you can return slow, and this will be the cycle starting point. Okay, let's submit the result to see it works. Oh, sorry, here's typo. It should be fast.next.next because fast are traveling at double speed. Okay, now let's submit again to see it works. Okay, you see the time capacity memory usage of this solution is not bad, right? And I hope my explanation is helpful for you. If you like this video, please subscribe to my channel, and I see you next time. Thank you.